Here we're going to look at the 5 basic shapes of molecules, and these basic shapes will not include any lone pairs. It's absolutely vital that you remember these 5 basic shapes. You need to remember how to draw them, you need to remember the names of them, and you need to remember the bond angles. So there's no excuse, you have to remember these 5 basic shapes. We're going to start at number 1, where I've got 2 bonding pairs of electrons around a central atom. My central atom here is beryllium, and I've got 2 bonding pairs around that central atom. And an example then will be something like BeCl2. That would be an example of 2 bonding pairs of electrons around this central atom, which I'll highlight in green. This is my central atom, and we've got 2 bonding pairs around it. And remember that these pairs of electrons are going to want to try and get as far apart from each other as possible to minimise the repulsion. And when we've got 2 bonding pairs of electrons, they arrange themselves in such a way where they give what we call a linear molecule. So the name of this shape is linear. The bond angle around the bond angle between the bonding pairs, so it's this bond angle here, is obviously 180 degrees. So if I've got 2 bonding pairs of electrons around a central atom, I get a linear shape with a bond angle of 180 degrees. The second of my basic shapes would involve 3 bonding pairs of electrons around a central atom. In this instance, my central atom is a boron, and we've got 3 bonding pairs around the central atom, and the example is BF3. So that's my central atom, and I've got 1, 2, 3 bonding pairs around it. Again, they arrange themselves in such a way to be as far apart from each other as possible to minimise the repulsion. When it does that, it gives you a shape with a bond angle there of 120 degrees, and it gives the name of the shape as being Trigonal Planar. And again, you need to remember the names of these shapes and the bond angles. Now, the third of my basic shapes involves 4 bonding pairs of electrons around a central atom. And this time I'm going to look at methane as my example. Now, I'll just go quickly back to this trigonal planar just to explain the name of this shape. It's trigonal planar, well, actually triangle, and it's planar because all these bonds are what we're calling the same plane. And it's easy to see this if you were to look at a 3-dimensional model. Now, in the case of a molecule with 4 bonding pairs, only 2 of these bonding pairs are what we call in the same plane. 2 of these atoms now, or 2 of these bonds we should say, now are not in the same plane as the ones we've just drawn here. One of these bonds then is what we call in front of the plane, and this is represented by a wedged bond. And we say then that this bond here is in front of the plane. What we've got to think of is that this atom is sort of pointing out towards me, out through the screen. We also have one of the bonds going what we call behind the plane, and that's represented by a dashed bond. So we'd say this is then behind the plane. So we can imagine that bond is sort of going back behind the screen there. So now we've got my 4 bonding pairs around the central atom. The central atom is being carbon. And when they arrange themselves in such a way to get as far apart as possible to minimise the repulsion, that gives me a bond angle between the bonding pairs of 109.5 degrees. And the name of this shape now is called a tetrahedral. So the name of the shape is tetrahedral, and again, that's something that you need to be able to remember. Why is it called tetrahedral? I think it's because when you draw this shape like this, then you get a shape with 4 faces. Tetra meaning 4, hedral meaning faces. The fourth of my basic shapes is when I've got 5 bonding pairs of electrons around a central atom. And here we're going to look at PF5. Now with PF5, the first thing is we've got a trigonal planar structure. So I've got a trigonal planar structure there, and as such, this bond angle here is going to be 120 degrees. So in effect, what I've got there is this trigonal planar structure. The difference now is to make it, or what I'm going to do to get 5 bonding pairs of electrons around this central atom, which is my phosphorus, I'm now going to add a bond directly above and directly below. I'm just going to make this bond a little bit straighter. And that gives us my shape for a molecule with 5 bonding pairs of electrons around a central atom. Now, we call these 3 atoms here that kind of go around the phosphorus. We call these 3 atoms here, and I'll circle them in blue. We call these 3 atoms here, these are said to be, in the equatorial position. And the atoms above and below the phosphorus, that I'm going to put in green, these are said to be in the axial position. The bond angle here would be 90 degrees. So actually we've got a molecule, when we've got 5 bonding pairs of electrons around a central atom, we've actually got 2 bond angles, one of 120 and one at 90 degrees. And the name of this shape is called a trigonal pyramidal. Because when you draw lines between these, we get basically 2 triangular based pyramids, one above and one below, the bases of each pyramid touching. Again, this is much easier to see if you've got 3-dimensional models, which I'm sure when you're in your classroom, your teacher can show you 3-dimensional models of each of these molecules. The 5th and final basic shape is if I've got 6 bonding pairs of electrons around a central atom. And an example here would be SF6. So sulfur is my central atom, which in each case I've highlighted in green. And what we get then is we get 1 above, 1 below. Then we get 2 coming out in front of me, 2 wedge bonds, and 2 going behind me, 2 behind the plane. And the bond angle between all these is 90 degrees, which again is not as easy to see on a 2-dimensional screen. But if you ever have a look at a 3-dimensional model there, it is quite easy to see that all these bond angles are 90 degrees to each other. And again, the name of the shape is octahedral. Again, I think it's because if you draw lines sort of between these, I can't really show you on a 2D board, but if you were to draw lines on these, the basic shape of this would give you a shape with 8 faces, which is why it's called an octahedral molecule. There are the 5 basic shapes, and you need to be able to remember how to draw each shape. You need to remember the name of the shape, and you need to remember the bond angle in each case.